you need to condense this into a single logarithm. I'll give you 3 minutes to try it, and then we'll go over it.
I know, like the whole album, but it's going to be awesome. It's like Kyle. No, he emailed me at like 1 a.m. He's like, Kyle, the music is screaming at me. Yeah, well, I remember the one you said.
Yeah.
The one I
Which one?
You said.
The one I said.
That's why you're my second favorite.
Okay, I'll take it. Okay.
Miss Cologne, but you can go.
I guess I have to do more strawberry. There's like 4 left in here and like 1,000. What happened? I didn't like neither. The first day I brought it in, I brought in just a strawberry, and they're like, no, Mr. Lake, apple cinnamon. I think the numbers speak for themselves. Strawberry is so much better. But also, all that conversation just went on the video recording. So for every class of pre-calculus I'll ever teach in the future, we'll hear this discussion. Yeah. I do not. Bear does the Spotify. I just Pandora, and then if I like something, I'll just buy it. And then, yeah.
I'm emailing you the Spotify link. I'm just emailing you.
I could probably Spotify if I had to, I imagine, figure it out. I am hip. I am with it, okay? Yeah. All right, what do we do with this? How do we condense this? What's the first thing we do? Yeah, make it a power on each one. Distribute that 1/5. Okay, how do you draw arrows? Your arrows are supposed to look like that. Great. All right. You didn't really have to make it a 5th root, but that's what it is. If you just raise that as a 1/5 power, that's fine too. But it is a 5th root. 1/5 is the 5th root. All right, what about this old minus sign? What do we do with that? Yeah, that's a good question. Yeah.
Yeah, we make it.
Make it a division problem. Yeah. So then this will become this. Okay. All right. Let's try. There we go. That's good. And then in the denominator. Okay. And then we have another minus. So then this term will also go in the denominator. So we're just going to do that one more time. Again, putting that in the denominator. And since they're both fifth roots, I'm just going to put them together like that. Is that okay with everyone? They're both fifth roots. They both go in the denominator. So I'm just going to put them in the denominator under the radical. But you can actually multiply those together because those are conjugates. It'll reduce to something really cool. X squared minus 1. Yeah. I think I could just make this one giant fifth root if I wanted to as well. But I'm not going to because why not? I don't want to. I mean, okay, hold on. I changed my mind. I'm doing it. I'm gonna make this one big fifth root. Yeah, I like that better. Final answer. I think you have one of those on the quiz, though I don't think it was as big as this one.
Like we had one?
Uh-huh.
Oh.
I think that was the one I got the most questions in class. I probably should look at score. I just assumed it'd be the worst. All right, questions about the bulwark. Okay, the plan for today is to do the lecture portion for 3.4, and then tomorrow you'll have the whole class period to work. Personally, I think 3.4 is not too bad, but you all will be the judge of that. Does anybody need more time to write? Okay, here are our goals for 3.4. We're going to solve simple. To be honest, we've already done that. Solving simple exponential and logarithmic equations, we already did. Solving complicated exponential equations and solving complicated logarithmic equations is really the goal, and then being able to use that to solve word problems. All right, so here are our simple equations, and this is kind of like we were doing last week. To solve these, you really just need to remember this rule, that any exponential equation a to the y equals x is the same thing as a logarithmic equation of log base a of x equals y. Those are the same thing. So if I want to solve the first problem here, 2x to equals 2 to the x power equals 32, all I'm going to do is change it from an exponential to a logarithm. This would be log base 2 of 32 equals x. And then you can do that in a calculator, or to be honest, it's probably faster to do that one in your head. 2 to the what power is 32? How many times do you have to multiply 2 by itself to get to 32? 4, 8, 16, 32. It's 5. Yep, x is 5. And you can do that in a calculator, log of 32 divided by log of 2. Or if you go into the math, you could do the change the base. Okay, the other rule that you need to remember to do these is the one-to-one property. So like for the second one, I could rewrite this as log base 4 of x equals log base 4 of 8. If I just move this to the other side, add the log base 4 of 8 to the other side, you get that? And then this equation will only be equal, since they're both logs, they both have a base of 4, if x is 8. Okay, those are two things that you need to know to be able to do this. Let me run through the rest of these really quick. So for example, for this one, that would be the same thing as the natural log of x is equal to the natural log of 3, which means that x is 3. For this one, it's in an exponential form. So again, instead of having it in that form, we can rewrite it as a logarithm. Log base of a third of 9 is equal to x. So a third to what power is 9? Now this one you might need a calculator, or I believe it's -2. 1/3 to the -2 power would be the same thing as 3 to the +2 power, which is 9. All right, we're having a negative exponent, you flip it. If it's already in the denominator, it'll come out of the denominator. E to the x equals 7, change that from an exponential to a logarithm would give us the natural log of 7 equals x. Does everyone see why it's a natural log? That's the same thing as log base e of 7. Log base e is the natural log. So this one you will need your calculator. Natural log of 7 is a decimal. It's 1.946. Okay, I gotta pause so I can erase some of this. I'm running out of room. Does anybody need more time to write those first 5? Questions about the first 5? Okay, for the last 3, we're just gonna do the reverse. The rate as logarithms, we're gonna change them to exponentials, and that'll give us our answer. So for this one, again, that's the same thing as log base e of x is -3. So if I switch that using my rule, that means e to the -3 is x. And again, you'll need a calculator for that. E to the -3 is 0.0450 actually. That would become, if we rewrite that as a logarithm to an exponential, 10 to the -1st equals x, which means x is 0.1 or a 10th. Either answer, I suppose, is okay. And then for the last one, again, it's written as a logarithm. We'll rewrite it as an exponent. So it'll be 3 as the base, power is 4 equals x. 3 to the 4th is, I believe, 81. Right? Yeah, that's right. So for these simple equations, you will again do one of 2 things. The most common thing you're going to do is just, if it's an exponential, you'll rewrite it as a logarithm, go to the calculator. You might be able to do it in your head. If it's a logarithm, rewrite it as an exponential, go to the calculator. You might be able to do it in your head. If you can get them set equal to each other, like an exponent equal to another exponent or a log equal to another log, then you try to apply the 1-to-1 rule like we did for B and C. All right, anybody need more time? You ready to try some? All right, here's 4. I'll give you 3 minutes. Didn't we do the last one already? Or did we do the reverse of that? Okay. Yes. So the 23rd is the last day you're at school next week. So you have the 24th, 25th, and 26th off. And then we start again on the 29th. Okay, Walker, you start it off. You didn't. Help. I'll help you out.
I'm just kidding.
I think you did those. I think it's- it's me. I'm just doing it. Yeah. You gotta rewrite the equation. Move the e to the x to the other side. And then rewrite. To rewrite this as a logarithm. What do I get? The first one. Yeah.
2x. Oh, like that? Oh,
What did you do?
I didn't think how the first one.
You wrote 2 to the x equals. Oh, yeah, that works. That's the 1-to-1 rule. So you rewrite it as a power of 2 and then they match, right? The x and the 9. Yeah, that totally works. That's not how I was thinking, but yeah, that works. Totally, totally fine. Perfect. Good job. I'm glad I called on you. All right. Bum, 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 bum. Did everyone see that? If you could rewrite the second one as a power of 2, then they have the same base. And again, if the bases are the same, then the exponents will have to be the same. So you can just rewrite 512 as 2 to the 9th, and then set them equal to each other. All right. 2, 5. That's Canaan. All right, Canaan. Well, I'm glad I'm calling on all the best people today. We have to rewrite this as an exponent. So what is the base? Okay, and then it'll be to the power of 3, and then it'll equal x. So then we just say, what is 6 cubed? 216? 216. All right, thanks, Hayden. 5-1. Kyle. That's you. All right, what should we do? So I gave you a hint, or I kind of gave it people a hint with the blanks that I had to erase because I have to share screen. How do I, what's the first thing I should do here? Yeah, we want to move the e to the x to the other side. So you get 5 is equal to e to the x. And now what? Yeah, we're going to rewrite this as a log. So this is log base e of 5, which is really just the natural log of 5 equals x. Calculator.
Yeah.
Also, if you did the first one with the logarithm, to type that in, you do log of 512 divided by log of 2, and you get the answer 9. For this one, we just have to do the natural log of 5 you get the answer 1.609. That's a 1. There's a 1 right there. See that right there? That's a 1. That's the number 1 right there. 1.609. All right. Last one. Let's go with somebody who hasn't talked today, who really wants to. I can tell that. Malachi. All right, Malachi, I have to rewrite this as a logarithm. What is the base of the logarithm? What are you talking about? Who said 9? Malachi, that's right. I don't know why you wrote a third, but it's 9. Okay, good job, Malachi. It's 9. Log base 9 of what? Of a third equals x. I was just so excited to write that third, I wrote it too early. All right, so now we type this into the calculator. So this would be log of a third divided by log 9. Or if you hit math, you can go in, and I believe it's option A. If you have a new enough calculator, you can type in 9 1/3, and you'll get the answer -1/2. 9 to the -1/2 power is 1/3. Because the idea here is 9 to a -1/2 power. Well, that's just 1/9 to the half power. And remember, a half power is just a square root. The square root of 9 is 3. So you get a third. Yay? All right, that's the simple stuff. Okay, now we're going to do the more complicated stuff. But to be honest, C, I pulled a little trick here. C is a complicated one. And it's not a simple one. The other ones were simple. Close. C says 1.609. That's a 1. Oh, didn't know the 9? Okay, hold on. Let me fix that. 9.
That looks like this is wine.
And then N. Okay.
That looks like
That's a
egg.
parabola.
Okay, that's an N. Good.
You just spell
There you
it
go.
out.
This
You
is
just spell
clear.
it out.
I can't make this any
Spell it
clearer.
out, Ed.
I really can't. All right. Here we go. Solving complicated exponential equations. It's as easy as 1, 2, 3. You're either, you're gonna first always get the exponential term by itself, or if you have more than one exponential term, then you'll use the 1-to-1 property, where if a to the x is equal to a to the y and they have the same bases, then x and y are the same. Once you have the exponential term by itself, you will rewrite it as a logarithm. And then you'll solve the remaining equation for x. Check your solution by graphing the original. One, two, three. And again, if it's a 1-to-1 property, really you'll just do it in 1, 2. You'll write them equal to each other and then you'll solve it. You ready to see one? It's pretty exciting. Okay, let's do it. All right, let's do both of these. So I have my exponential term right here, 2 to the x. I want to get it by itself, so I need to get rid of the 3. What's the opposite of multiplying by 3? And divide both sides by 3, and we get 2 to the x equals, what's that, 18? Is that right? Am I just making stuff up? No, it's not 18. What is it? 14. Who said 18? Malachi? Okay, so now you have 2 to the x equals 14. You have the exponential term by itself. So now we're going to rewrite this as a logarithm. So this will be log base 2, or base is 2 of 14 is x. Calculator. Nope. 3.807. And you have to, when you're doing this in WebAssign, make sure you read the directions carefully, whether or not they just want you to leave it as a log, or if they want you to do it in the calculator and tell them the decimal. And to what, how many places they want the decimal, where you should round, all that good stuff. Or you just do, you know, where you put the answer in 3 times till it tells you the right answer, right? And then you just copy paste the right answer. What?
What? I was saying I would never, ever do that.
Nobody in this class would do that. That'd be silly.
Just look on my home
I would,
button, it's
that
all
would
plus
make.
All right, B is about as hard as these get. I want to get the exponential term by itself. I want to get the e to the 2x by itself. So I need to get rid of the 4 and the -3. How do we get rid of the -3? 4 e to the 2x will equal 5. To get rid of the 4, you divide. And now I'm going to rewrite this. Now that it's in this, now that it's in exponential form, I'm going to rewrite this as a logarithm. So it'll be log base e of 5/4, but really that's just the natural log of 5/4 equals 2x, because the exponent is 2x. So this one, we have one more step to get x by itself. We have to get rid of the 2. To get rid of the 2, we would divide. So the natural log of 5/4 divided by 2. Which easy beat. .111. 0.112 to be round. 0.112.
So if the exponent is like some crazy thing, like 2x plus 5 minus blah, 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 blah,
Yeah.
we just solve.
Then you'll just solve it algebraically after that. Add the 5, divide by 2. Okay, let's say that you're sitting in this classroom right now on this fine Monday morning, and you were thinking about what you wanted to have for lunch and didn't pay attention to anything that I just said. And you would like a quick and easy way to get these answers. You could always do these by Desmos. You can just graph it. And your Desmos RTI84. So we got 3 to the 2x equals 42. Answer it. Hey, stop it. Oh, shoot. No, I don't want to do this. Let me put it as a y equals. That'll give it better. That'll let me click the point. Minus 42. There we go. Now I can give me a dot. 3.807. Boom. Or the other one was what? Y equals 4e to the 2x. And then if I move this to the other side, it'd be minus 5. Minus 5. 0.112. Yay. Isn't that cool? All right. I'm gonna have, does anybody need more time to write? Okay.
Oh my God.
Your turn. Try these two. I don't know if we're gonna get fully through the lecture. We might not be able to do the word problems.
I think it's for him.
Right.
Why did I think about that? It was just not, it was not. No, we'll do them as like, I don't know, make one of them about work tomorrow. The word problems are real stuff, real deal. Ah. You're gonna use this in your everyday life. It's okay, it's just my niche. I didn't need that anyway. I'm gonna walk around. If you need any help at all. Math, English, need something for art class, you just let me know, I'll help you. No, okay, so you have two options, either do log 16 divide log 5. Yep, that'll work, or if you hit math. you go down. Oh, wait, maybe yours doesn't have it. Well, yeah, yours doesn't, it's too old. That, you got one option, log 16 divide log 5. Ah, that's right. I don't know if that's right. Okay. Well, this is fine. I think it should, yeah, I think that should turn out okay. It's just different, like formatting. Same app, but they're different. All right, right, log base what? Log base 3. Things anyway. Ian, you're the lucky person. What do I do first? If you say so, I'll do it. What does that get us? 5 to the x equals 16? Now what? Heck yeah. Calculator. Log 16 divide log 5 is 1.72. Okay. If you wrote on your paper 1.722, 1.723. 7 means you got to round up. One 1.723. All right, thanks, Ian. All right, next. 4, 5, 4. Nobody. That's a spot. 5, 6. Also nobody. 2, 3. No. Okay, hold on. What's going on here? 2, 1. What are the chances of this right now? Tristan. It was just all a big setup for Tristan. All right, Tristan, what do I do first?
You see what you do?
What do I do?
It's the math.
What's the math?
You add 4 to both sides.
I'll do it. I did it. Now what?
Well, then you're gonna divide by 2 on both sides.
I did it again.
Yep.
Okay, hold on. I didn't really do it yet. Okay, now I have done it. Now what?
So then you do log base 3.
Yes.
7.5
Equals?
equals 2t minus 5.
Okay, and then that's just a big decimal.
Yes, which I got 1.834.
What are we going to do to that decimal? How do we get, we need to get t by itself. How do I get rid of the 2 and the minus 5?
Oh, you have to add 5 to both
Add 5.
sides.
And then how do I get rid of the 2?
Then you divide it.
Okay, that's what's going in my calculator. So let me show you something that will make you not lose points in web assignment. So if I do log of 7.5 divided by log 3, I don't want to do 1.834 plus 5. I want to do the whole decimal. So you just hit plus 5, it'll copy the previous answer. Okay. And then if you hit divide 2, it'll copy the previous answer and divide it by 2. You should get 3.417. If you round and then, add and then round it again and then divide and then round it again, you made 3 rounding errors, and that could move you enough so that you're off by 1,000th or 10,000th, whatever decimal they want you to go to, and then they'll say it's wrong when you just rounded too much, right? Should be 3.417. Also, you can hit second answer to pull up the previous answer, or if you have the nicer calculators, you could just go up and you could just copy the previous answer. Yeah, second negative sign will give you the previous answer, and it'll copy the entire decimal without rounding. But we want final answer 3.417. Okay, how do you write 3.417 like that? Yay. We have 5 minutes left. I'll show you the slide for how we do. Oh, hold on. Sorry. Does anybody need more time to write? Okay, I will show you the slide on how we do logarithms. Maybe I'll do one and then we'll just call it good. You will do logarithms in a very similar process. You're going to get the logarithm term by itself. Or if there's more than one logarithm, you might set them equal to each other. Oh, I forgot to change this. Oh, gross. Did I change it on your paper and I just forgot to change it here? It should be, I think I did. Log base A of X is equal to log base A of Y, if and only if X is Y. Okay. So if your logarithms, if you have 2 logarithms and you get them equal to each other, then the logs will cancel out and you'll just have X is equal to Y. Otherwise, you get the logarithmic term by itself, then you rewrite it as an exponential using the exact same rule. Then you solve for X. Okay, I said you could check the ones for graphing before as a nicety. You have to check your answer for logarithms because the domain is only positive numbers, right? So if you get an answer that's 0 or an answer that's negative, it may not actually work if you plug it back in. You actually do have to check your answer. You can do all the math correct, and at the end, it's the wrong answer because it's extraneous. So I'll just show you one. It's the same thing. I want to get the natural log of X by itself. So I will subtract 5. I'm just going to do 1. You can hold on and just pay attention if you want. Divide by 2. Natural log of X is equal to -1/2. Once you have the natural log by itself, rewrite it as a power. E to the -1/2 is X. Does everyone see where the E came from?
Yeah.
Natural log has a base of E. We do. Calculator. And you get your answer. Okay, but you're not, you gotta plug it back in. Is 5 + 2 natural log of that answer? Is that really 4? It is. That one works. The next one will not work. There'll be one that doesn't work. All right, that's the end of class for now. We'll do the second one as bell work tomorrow, and then we'll do the application questions, and then we're done. Oh, it should be 6:07.